Right, in this video we are talking about probability, but specifically with two-way tables. So this is 4.3 Part A. I'm splitting it into two parts. Part A was two-way tables. Mutually exclusive events, A and B, cannot both happen at the same time. For such events, A or B, means that only event A happens or only event B happens. It can't happen at the same time. There's no way it can happen at the same time. So mutually exclusive, you're either one or the other. You have a job, you don't have a job. You have a dog, you don't have a dog. You can't be both. So you can find the probability of A or B with what's called the addition rule for mutual exclusive events. If they are mutual exclusive, this is all you have to do. The probability of A or B is just the probability of A plus the probability of B. Now, this rule only works if they are mutually exclusive. So then how do you find the probability of A or B for two events that are not mutually exclusive? Now we have to deal with the fact that the A or B means one or the other. When you're trying to find probabilities involving two events like A or B, a two-way table can display the sample space in a way that makes probability calculations much easier. So here's a two-way table. All right. When you're trying to find probabilities involving two-way events like A or B, a two-way table can display the sample space in a way that makes it much easier. Consider this example about pierced ears in males and females. Okay, males and females can both have pierced ears. So this is the table of 178 people surveyed, and they were asked, are you male or female? Do you have pierced ears or not? And this is the result of that combination. So you know that this is not mutually exclusive because you have values in every single inner square. If one of these was 0, then there would be something mutually exclusive. But this is not mutually exclusive, so we have to think about how do we do probabilities with this table. So we can't use the basic addition rule for mutually exclusive events unless A and B have no outcomes in common. In the example, there are 19 outcomes that are shared by event A and event B. The students who are male and have pierced ears. If we did add the probabilities of A and B, we would get 90 out of 178 plus 103 out of 178, which would give us 193 out of 178, and that should bring up a red flag that that's not right because it's greater than 1, and no probability can be greater than 1. So there has to be another way. So we fixed the double counting problem, illustrated in the two-way table, by subtracting the probability that they're male and they have pierced ears, like the overlap of the two. You subtract that from the sum. And this gives us what's called the general addition rule. Write this down. If A and B are two events resulting from some chance process, the general addition rule says that the probability of A or B is the probability of A plus the probability of B, subtract the overlap probability of A and B happening together. So here's the sample problem. Students in an urban school were curious about how many children regularly eat breakfast. They conducted a survey asking, do you eat breakfast regularly? All 595 students in the school responded to the survey. The resulting data are summarized in this table. Suppose we select a student from school at random, define event F as being female. Okay, event F means you're female, so not event F would mean you're male. Event B is eating breakfast regularly. Okay. Now, so part A says find the probability of the complement of B. So B is eating breakfast. So the complement of eating breakfast is not eating breakfast. So I look at complement of B is looking at the breakfast question and it's a no. That's the complement. So what's the probability that they did not eat breakfast? So I would look at my total over here. It's 295 out of the table total, which is 495. And that's where I get this fraction, 295 out of 595. And that gives me a decimal point, 496. Then it says to interpret the value in context. So here's how you would interpret it. There's about a 50% chance that the randomly selected student from the school does not eat breakfast regularly. Notice it's in context, notice it's a complete thought, and it has the probability it's rounded here. Part B. Find the probability that there's female and that doesn't eat breakfast regularly. Okay? So female and doesn't eat breakfast regularly. So female is right here. Doesn't eat breakfast regularly is the no row. So I look at that overlap. Where do they overlap? Right here at the 165. So it's 165 out of 595, which gives me 0.277. This question does not ask me to interpret, so I don't have to worry about that. On C, the probability that they're female or they do not eat breakfast. So notice the calculation. The denominator on all these fractions is 595, so I write it as one big fat fraction. The 595 is the table total over here in the corner. So I look at probability of being female. Probability female in yes is 110. Probability that they don't eat breakfast is, and they're female, is 165. So there's the 165. And the 130 is that they're not male. So keep in mind this means not male, which would mean female. So that's where the 130 comes from. So those are all separate spaces. Okay, there's no overlap here. So I add them up and I get 405 out of 595. And then the decimal version of that is 0.681. Could you have gone about this a different way? Sure. You could have taken this 275 total right here, the whole female total, and added the 130, and you would have gotten the same answer. But the idea is that you find everything that is female, which means not male or female, and they do not eat breakfast. So here's another type of problem you're going to see on your homework. The table shows the number of girls or boys, that should be an or, who can swim. All right, so you're going to get a partial table, and using addition and subtraction, you're going to fill in the gaps. I've already done that in this table, so I'm assuming that you can do that on your own. So part A just says complete the table. Part B, what's the probability that it's a boy? Okay, so look at boys, and I look at my total for boys is 564 out of the table total of 864, or 894, I'm sorry, 894. And that's where I get this. And I would convert this to a decimal, I just didn't put it on the slide. Decimal to 3 decimal places. Part C, a girl who cannot swim. So then I look at my girls column and the can't swim, the overlap, girls that cannot swim. That's 216 out of the table total of 894. So there's the fraction. I would make this a decimal in my answer and box the answer to 3 decimal places. D, a child who can swim. So here's my children who can swim. And it's the total there is 289 out of the table total 894. Again, convert this to a decimal. I didn't do it on the slide, but convert to a decimal, round it to 3 decimal places. On E, a boy who can swim. So I look in the boy column, and the can swim is just this part right here. So it's 175 out of 894. And then whatever decimal that gives me, that is my answer. Okay, hopefully this gives you a good idea of how to use the two-way tables to find given probabilities. Thanks, and we'll see you in class.